station WXM80 broadcasts on a frequency of 162.475 megahertz. This is Winter Weather Awareness Week. Please join the National Weather Service in promoting winter weather education, including safety. The topic for today is winter floods. Coastal storms can produce heavy rain, high winds, and storm surge that can last for dozens of hours or even a few days. Strong onshore winds will cause an abnormal rise of water above astronomical tides, called storm surge. If the storm surge coincides with high astronomical tides, it will likely produce coastal flooding. The onshore winds are typically produced by a combination of high pressure to the north and low pressure to the south. The strength, duration, fetch of the onshore winds, the heights of astronomical tides, and coastal geography and topography are the primary determinants of the magnitude and areal extent of flooding in specific location. A recent high-impact coastal flooding event occurred on December 22nd into 23rd of 2022. Southeast to south wind gusts of 55 to 65 miles per hour developed ahead of a rapidly deepening low pressure over the Great Lakes region that slowly tracked into southeast Canada. These high winds developed a storm surge of 3 to locally 4 feet, coinciding with an astronomically high tide Caribbean spring tide on the morning of December 23rd. This resulted in widespread moderate to major coastal flooding along our coast, with Bayfront communities in southern Nassau and southern Queens reaching water level experience during Tropical Storm Irene. Persistent onshore winds and waves over several tidal cycles can prevent waters from receding, particularly in Bay's areas, after high tide. This is referred to as tidal piling, making tidal flooding worse with each passing high tide. A slow-moving storm and strong high pressure to the north can amplify these effects. The historic December 1992 nor'easter was a prime example of this, causing widespread moderate to major coastal flooding on 4 consecutive tidal cycles, peaking with widespread major inundation of 3 to 5 feet for many coastal communities. Coastal flooding can even occur for our most vulnerable coastal and shoreline communities during otherwise quiet weather conditions due to high astronomical tides. The highest astronomical tides, called Caribbean spring tides, occur when there is a new or full moon coincident with it being at its closest elliptical orbit to the Earth perigee. The quiet weather flooding can be exacerbated by a persistent offshore low-pressure system sending waves and piling water along the coast. This occurred during the Halloween nor'easter of 1991 that was stalled well north and east of the area, but still caused widespread significant tidal flooding under partly sunny skies. Heavy rainfall can compound tidal flooding impacts. The winter of 2024 featured a few intense December and January storms that tracked west of the region, bringing compound flooding from both heavy rainfall and storm surge. Heavy rainfall caused widespread moderate to major flooding of rivers, streams, and adjacent low-lying areas during these events, compounded by high astronomical tides and 3 to 4 feet of storm surge, bringing widespread moderate to major flooding for coastal communities and along tidal rivers. Heavy rain and snow melt also pose a compound flood risk. Following the blizzard of January 7th and 8th of 1996, strong south winds brought in mild air causing rapid snow melt, which in combination with heavy rain caused widespread severe urban, river and small stream flooding, and many roof collapses. Finally, for riverine adjacent locations north and west of New York City, flooding can be caused by ice jams. As river flow increases,